Hi everybody and welcome back to Magnificent Math with Mrs. Murray. Bum, ba, dum, ba. Today we are talking about adding and subtracting rational expressions. So I've given you some notes on your handout which you should be able to refer to, but basically what we need to remember in this section is that adding and subtracting rational expressions, we follow the same rules as we would when we're adding and subtracting fractions. So if you think back, what you should remember is that when we add or subtract rationals or fractions, we always need to find a common denominator. Once we find that common denominator, we can add across the numerators, and then we leave the denominator as that common denominator, and then we simplify at the end. So I'm not going to go over the notes that you have. You should be able to read that. It's just talking about when we have the same denominators or different denominators, and talking about how we find our lowest common denominators in those situations. But the questions that we work with today should progress and get more difficult, and they'll have denominators that we need to make common. So let's take a look at this first example of 2a over b minus a minus 1 over b. And what we want to do is determine the non-permissible values. So it's just a straight up subtraction question. So what we should be able to do is identify that as b cannot equal 0. And then what we're going to do is we're just going to simplify. So in the numerator, since we already have a common denominator, our denominator will stay as b. In the numerator, we'll have 2a minus a minus 1. When we distribute the negative to the a, it becomes negative 1. And we distribute this through, it becomes positive 1. 2a minus a gives us a. And this should actually, I've now realized, that should equal positive 1, not negative 1. Okay? And then our restriction, of course, is that b cannot equal 0. Okay? This example here, we've got three different terms, okay, but they all, again, share that same denominator of x minus 2. So we don't have to find a common denominator, and what we can do is we can rewrite the numerator over top of that same common denominator. So we've now written it as one term, so we have x squared plus 3x minus 10 over x plus x minus 2. And then what we're going to do is we're going to factor that numerator. So we find two numbers that add to 5, multiply to negative 10. So we have x minus 2 and x plus 5 over x minus 2. Then we're going to determine what our restriction is, so x cannot equal 2. Then we can simplify in the next step, so we eliminate the x minus 2 and the x minus 2. When we divide those, we get 1. So your final answer would just be x plus 5. Okay, so those are both very simple because all of the denominators were common. In this next example, we're going to find that we don't have a common denominator, so we're going to have to find one. Before we can find a common denominator, the first thing we want to do is factor. Okay, so we're going to factor these trinomials, and this is what we end up with. So we have x minus 1 over x plus 3 multiplied by x minus 2, and then minus x minus 2 over x plus 3, x plus 1. So again, I just factored in this first step, going into the second step. Okay, now what we need to think about is what the lowest common denominator of that is. Okay, in order for it to be a lowest common denominator, we have to find basically the greatest number of any factor that appears in that denominator. Okay, so we have an x plus 3, x minus 2, x plus 3, x plus 1. X plus 3 is common in both of them. Okay, but this x minus 2 and x plus 1 are not common. So our common denominator when we put them all together is x plus 1, x minus 2, and x plus 3. So now what we need to do is we need to take this original factored expression and we need to multiply it by a term that is going to give us a common denominator. Okay, so we have x plus 3 and x minus 2 over here. We're missing the x plus 1. That means we have to multiply this side by x plus 1 over x plus 1. Okay, in other words, we're multiplying it by 1. It's an equivalent fraction. Okay, it's an equivalent ratio, so we haven't changed the expression. On the other side here, you should notice that we have x plus 3, x plus 1. We'll have to multiply it by x minus 2 over x minus 2. Okay, when we do that, we end up with x squared minus 1 in the numerator. So we FOILed these two terms. So x multiplied by x gives us x squared. Then our inside terms become x plus, or 1x and negative x. And then our last term is negative 1 when we FOIL it. Subtract, same thing here. We're FOILing x minus 2 multiplied by x minus 2. When we expand that, we get x squared minus 4x plus 4. And that's going to be over the same denominator of x plus 1, x plus 3, x minus 2. From there, we rewrite the numerator without the brackets. So we're going to distribute this negative through to get negative x squared plus 4x minus 4. And then we're going to simplify to give us 4x plus 5. So our x squared terms cancel out. We have negative 1 and negative 4, which gives us negative 5 and a 4x. Denominator stays the same. From there, we cannot simplify any further, but we do need to consider what our restrictions are. And our restrictions are that x cannot equal negative 1, negative 3, or positive 2. So this here is your simplified answer. Okay, and the last question, they've already given us the restrictions, so we don't need to worry about that. But we have x plus 1 over x divided by x minus 1 over x. So it looks a little bit tricky, but it's actually quite simple. It takes a little bit of time, but we can do it. So first thing we have to do is find a common denominator. In the numerator, we have an x in the denominator here, but we don't have it over here. What we need to do is multiply 1 by x over x, which would give us x over x plus 1 over x. In the denominator, we also need a denominator in this term of x. So we multiply this by x over x to give us x squared over x minus 1x. Okay. The next thing that we're going to do is combine these. So we have x in the numerator plus 1 over x, which is what we get down here. Then we have x squared minus 1 in the numerator over x. Okay, our next step is to rewrite this. I always like to rewrite it so that it's easier to follow. So we have x plus 1 over x in the numerator divided by this whole thing. So I like to write it sideways so that we have negative, or so that we can see the division. So we're dividing it by x squared minus 1 over x. And then we should know we need to multiply that by the reciprocal here. So we flip this to become x over x squared minus 1. Now it's become a multiplication question. So we end up with, okay, sorry. So when we multiply this, what we can do is we can cancel out the x here and the x in the denominator over here, leaving us with x plus 1 in the numerator over x squared minus 1. And then from there, what we can do is factor that denominator. We have to factor it because it's not simplified. Once we factor it, we get x plus 1 in the numerator still. The denominator factors to x minus 1, and then multiplied by x plus 1. Simplifying here, we can cross out the x plus 1 and the x plus 1, leaving us with 1 over x minus 1. And that's your final answer. Okay, so even though we're adding and subtracting, like we have addition and we have subtraction here, this question ties in multiplication and division. So the rules from 6.1, 6.2 all still apply in 6.3. Always remember to factor before you simplify, and also state the restrictions when asked. And that's all for today.